So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is linked list lecture number 21. In this video we are going to discuss the question add 1 to a number represented as a linked list. So what does the question say? Suppose you have a linked list 4 connected to 5 connected to 6. This is your head obviously, right? You have to return me a linked list after adding 1 to it. That is this linked list is actually representing the number 456. If I add 1 to it, it will become 457, and thus my answer linked list will look something like 4 connected to 5 connected to 7, right? So this is my input and this will be my output, right? So I hope the output scheme of the question is clear to you. Now let us see the approaches. How will we solve it? So approach 1 says do it with a simple traversal. What do I mean by that? I will say that long number is initially 0, right? And suppose my linked list is 4, 5, 6. I will keep a temp at head. This is my head currently, right? I will keep a temp at head. And now, while my temp is not equals to null, that means I will keep traversing until my temp has not actually become equals to null. What will happen? I will say num is equals to num multiplied by 10 temp data, and after that you can say temp equals to temp equals to temp next, right? And after that you will get the num value as 456. How? Let us see. Initially as our num was 0 and a temp was here, right? Our temp was here. After that I will say num equals to num into 10, that is 0 into 10 plus temp data equals to 4, that is it becomes 4. Temp moves here, right? And after that what will I do? I will say 4 into 10 plus 5, right? That will be equals to 45, and temp moves here, that is 45 into 10 plus 6, that is equals to 456. Temp moves at null, and because it moves to null my loop will break, and you can see my number now contains 456, which I wanted. Now it is easier to carry an addition in the number which is represented as an integer form. So I will say number plus equals to 1, that is this number will get converted to 457. Now I can easily convert it into like something like string. Suppose I convert it into 457 using a toString method. And now what will I do? I will keep a temp here again. I will keep a temp here. Now what will I do? I will just start inserting it. So temp is equals to 4, so it will be 4 here. Temp moves to next, temp come here. I will be inserting this node, it becomes 5. Temp comes here, and I will be now changing 6 to 7, and as you can see I got my answer as 457, which I wanted. That is, I will say temp equals to head. First of all I will say s equals to toString of num. Now temp equals to head. Now what will I do? I will say while I is less than s dot length, right? Suppose I is equals to 0, starting from 0. Temp data will now be converted to integer value of s of I. You can say s of I minus 0. This will give you temp data, and you can say temp equals to temp next, that is move the temp to the next node for changing, and also I plus plus. In this way your linked list will get filled with 457. In this way your linked list will get filled with 457, which you wanted. But there is a certain problem in it. First of all, this is a hack. This is the first thing I want you to notice. This is the hack. Why? Because we are not actually dealing with the pointers of the linked list, right? And secondly, it is actually not visible. Why? Because number of nodes are given to me as 10 to the power 21. 10 to the power 21. That is a number. That is, if I take this approach of long num, my maximum number can go up till a certain limit because of the long constraint. But that limit is actually less than 10 to the power 21, because if I use 10 to the power 21, what is the maximum number I can form? I can form 9, 9, 9, 9. 10 to the power 21 times 9 will occur. 10 to the power 21 times 9 will occur, right? That number is not feasible not only in long, but in any data type in a C++, right? I guess big integer doesn't hold that much also, right? In the Java also, right? So how do we do it? We have to develop a new approach. So to develop a new approach, I would request you to go past in time, to go back in time, when you used to practice addition, subtraction, etc. Right? So if I give you a number 4, 5, 6 to you, How will, and I said plus 1. How will you carry this addition in the childhood, right? So you will say, bhaiya, I will say 6 plus 1 equals to 7. Now 5 doesn't have to add anything, to 5 will remain same. Similarly 4 will remain same, and 4 5 7 is my answer. Okay, now if I say please add 4 5 9 plus 1, how will you do it now? So you will say 9 plus 1 equals to 10. I will add a 0 here and I will keep a carry 1. 1 plus 5 gives me 6 and 4 remains as it is. So 4, 6, 0. I will say perfect. Now, I will use the same approach. First of all, there are few things to notice. You start with, you start with rightmost bit. You start with rightmost bit. This is the first observation. Second observation is, in a node, only 0 to 9 can occur. Only 0 to 9 can occur. If after addition greater than that, if after addition greater than that, then what will happen? If after addition greater than that, what will happen? I will have to take carry. Carry will come in place. Where carry will come in place. So this carry is 1. Can I say here the carry was 0, here the carry was 0, and here because 9 plus 1 equals 1, the carry here becomes 1, right? I can say that, right? So if you say 4 9 9 plus 1, what will this happen to? So currently carry is 0 here, 0 here, 0 here. 0 plus 9 plus 1 equals to 10. So 0 comes here, it changes to 1. 1 plus 9 equals to 10. 0 comes here, it changes to 1. 1 plus 4 equals to 5, and you can see my linked list is now looking at, my number is now looking at 500, which is the correct answer, right? So please take into carry that I am using this flow. I am going in this direction. We are adding in right to left direction. This is the important observation. We are adding in right to left direction. But the problem with this approach is that I have got 565, suppose, right? Now, in addition, we saw that this will be this will be getting adding first, then this, right? The suppose 0 0 0 is my carry, and I will add 1 here, right? We saw that this is the first one, this is the second one, this is the third one. But if this number is represented in linked list, it will be represented as 5 6. Let us say this is 4, right? So it is not a palindrome. 5 6 4 5 6 4. If I am using the native way of linked list, I will have to go from, this is the first, this is the second, this is the third, but I wanted something reverse of it. So I will use a reverse operation to convert it into 4 5 6, and now I can can carry my addition easily. So I will keep a temp here and I will start adding. I will keep a temp here and I will start adding. Initially my carry is equals to 0, my carry equals to 0, right? But I can take this carry as 1. Why 1? Instead of putting this 0 as 0, I will be putting this 0 as 1. You can see 1 plus 4 is still equals to 5, right? So I will say carry equals to 1 initially, temp equals to head, temp equals to head, right? So what I will do is I will just try to write while carry, what will happen while carry is present, or I can say while carry and temp, while carry and temp, that is temp does not become equals to null, right? What will happen? I will first change the data of temp. So temp data plus equals to carry, right? Initially it was 4, so 4 plus 1 gives me 5. Carry is 1, right? So it will get converted to 5. It will get converted to 5, right? But what if the linked list for something like 9 after reversal, 9 5 6, that is the number 569. So I will have to take the carry concept, right? Initially I said carry equals to 1 here. Now temp data after adding will become 10. It will become 10 here. I cannot store 10. I have to split it into two values, that is 0 and 1. 0 is my data, like my new data, because I have to store 0 here, and 1 will be my carry, right? So how to get 1 from 10 and how to get 0 from 10? So I will just use some operations, arithmetic operations. You can also try them out. So temp, before that, carry equals to temp data per divided by 10, divided by 10, right? This is not a modulo, let me change it. Yeah, divide by 10, divide by 10. Temp data divided by 10 will give me carry, the new carry, which will come here, right? Temp data will now get percentile equals to 10. Are you able to understand what I am doing? I am saying carry becomes temp data by 10. That is 10 by 10 becomes 1. Mission fulfilled. Temp data percentile equals to 10. That is equals to 0. 10 percentile to 10 equals to 0. You can see that for 12 also, if somehow 12 occurs, so 12 by 10 gives me 1, which is my carry, and 12 percentile 10 will give me 2, which is my data. That is also working out fine now. So my carry gets updated to 1 because it was 9 here. So my carry gets updated to 1. So I will have to add 1 here, right? After that, I will say just temp equals to temp next, right? So initially temp was here. Now my temp is here. When this loop comes on, then what will happen? Carry is also equals to 1 and temp is also not null. So data changes to 6. Data changes to 6. Now, because it was initially here, temp because of 6, what will happen because of 6? So 6 after 6 by 10 gives me carry as 0 and 6 percentile 10 gives me 6. So it will remain 6 here and carry will be 0. So that means I don't have to go further because carry has been finished and I don't have to add further. I don't have to add further. So the answer becomes 9, 6, 6. My initial integer was 6, 5, 9 plus 1. It becomes 660 and you can see 660 is my answer because it has been updated to 0, right? So 660 has been my answer. 660 has been my answer. Now, because we reverse it, if we reverse it again, it will become equal to 660. It will become equal to 660. But still, don't leave the video because there is still an edge case. What is the edge case? The edge case is we are actually doing temp data plus equals to carry etc, right? Temp is here. Temp is here. What will I do if 9, 9, 9? Add 1 to it. If I add 1 to it, what will happen? It is initially 0, 0, 0 carry. 9 plus 1 equals to 10. Change the carry to 1. 9 plus 1 equals to 10. Change the carry to 1. 9 plus 1 equals to 10. Now you can see that initially my length of the linked list was 3, but now the length of the linked list is 4 because 1 is getting added here. A new node is getting added. A new node is getting added. The edge case is a new node, right? So how will I get carry here? How will I do some stuff here? What will I do? So my linked list is 9, 9, 9 currently, right? After reversal, it will look like 9, 9, 9. Initially, my carry equals to 1. My carry equals to 1, right? Now my loop will say while temp and carry. While temp and carry. What will happen? Temp data plus equals to carry, and now change the value for the next operation. So carry equals to temp data by 10 and temp data equals to percentile equals to 10, right? These values are going fine. These values are going fine. The only case I want to handle is suppose my temp is here, it changes to 0, it gets 1 carry here. Temp comes here, changes to 0, gets carry 1 here. Temp is here, gets changes to 0, gets carry 0, gets carry 1, sorry, gets carry 1. Now the problem is that I have to add a node because my carry is still not gone. So what I will do is while carry because my carry is not 0 up till now. Temp comes here after this operation. My temp comes here. You can see temp is pointing to null. That is a case of problem here. So I will keep another pointer. Let us say previous, which is initially here, then here, then here, then here. That is previous. Previous is at the tail node. Previous is the at the end of the linked list, at the end of traversal. Previous is at tail. Previous is at tail. So previous is pointing here. Now it is easy to carry out. So what will I do? I will say previous next is equals to new node, right? And I will put the value carry here. That is, if previous is here, that is the node 0 is pointing towards, that is I will add this node and I will put carry here. Carry is 1 initially, right? Carry is 1. Now same operations. I will say previous equals to previous next and previous data carry equals to previous data by 10, carry equals to previous data by 10, and previous data percentile equals to 10, and now you can see this one will get absolutely easily, and 1 divided by 10 will give me a carry to be 0 and it will remain 1 only. So now you can see my linked list is getting sorted to 0, 0, 0, 1 with my head being here. Now I wanted the reverse of it, that is 1 0 0 0. This is in the reverse order because we initially reversed it. So I will reverse it and it will become like 1, 0, 0, 0. I can simply return it because my head is here and I will simply return it, and the linked list is actually presenting 1000 to me. which is my answer. So I have written the code down for you, this one. But before, you will have to do something like previous equals to null, and before going to next, that is previous equals to temp, and after that temp equals to temp next, temp equals to temp next, right? So I hope this was clear to you. What is the time complexity here? So it is O of n, because you are just using one traversal, right? It is O of n, or maybe less than that if carry gets finished before, right? And what is the space complexity? O of 1, because we have not used any extra space. So it is a well optimized code, right? Now it is time for you to see the code of it. So here is the coding section. I am using GFG platform for the sake of writing the code. So I have already copy pasted the code for reversal of the linked list. I hope that you know about it. If not, please find the video in the attached playlist only, right? You will find the playlist on the end screen. So you can find the reverse video there. Now let us start with the code of it. Let me make some space so that I can code it fine. Now what we will do? First operation was reverse head. And where do I have to store the reverse head? I will have to store it in the head itself, right? Head equals to reverse head. Now I will make a pointer previous, which will be initially pointing to null. So node star previous equals to null, and start temp equals to head currently. Start temp equals to head. Now moving on, what will happen? I will say my carry, as I said, I will initialize it with 1. Now while my carry is equals to not equals to 0 and my temp is not null, what will I do? I will say temp data plus equals to carry, and after that carry equals to temp data by 10, and temp data becomes percentile of itself, just to store a number between 0 to 9, right? Temp data percentile equals to 10. Now I will just say previous equals to temp before traversing. So previous equals to temp, and temp equals to temp next, temp equals to temp next. So it might be possible that carry still remains, because it might be possible that the last all of them were 9. So what will I do? I will say while carry previous next is new node, previous next equals to new node, the value will be carry there, and now I will say previous becomes previous next, previous equals to previous next, carry equals to previous data by 10, and previous data becomes percentile of itself, as we did above in the case of 10. Previous data percentile equals to 10, right? I hope this should work. I will simply return the reverse of head, because we reversed it once, so we'll have to reverse it again. Reverse of head. Let us try to compile and run it. Hope it will work fine. In the meantime, do consider subscribing to my channel, okay? So it is going fine for the sample test case. Let us try it for the submit button as well. It should run fine, and it is running fine. So thank you for watching. We'll meet in the next lecture. Till then, stay coding, stay updated, and okay, have a nice day.